Hello? 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 Hi, I forgot. uh, uh, what was loud? I got distracted. That's why it happened. I got distracted. Ugh. Also, I guess I came from the dentist. That's my excuse. I'm going with it. Alright, let's see if I can find my pen. There it is. Also, I was kind of eating dinner. Fake. Unreal. Not true. Oh, gosh. Let me see. I'm gonna pull up the quiz, the test, real quick, and not show everybody it. Grab food. I won't. So I'm just gonna go over what's on the quiz on the response first, if you guys don't mind. Oh, I should tell everybody before I begin. Share. Copy. This is how I do it. I'm gonna go to Parent Square and make an announcement. Unit 3 review. Unit 3 review FRQs. I won't tell your parents. I'll show only students. Post now. There you go. There's get that email. Only by like 20 minutes. No problem. There, I posted on that. Let's go Google Classroom too. Y'all got that email. Cool. Why? There you go. There we go. I changed the title of the stream too. Now it's chain rule, AP Calc chain rule forever and ever. Shall I begin? You'll be fine. Don't worry. Maybe you'll be fine. I don't know. Okay. So, don't forget your note cards that you are going to have to know the derivatives. That's just literally it. It depends on what you want to do or want to memorize, rather. So, whatever you need. One thing I want to note on too. So, I'm just looking. I know. I'm looking at the higher order derivatives. I mentioned this, but I didn't really like stay long on it. But I talked about position functions, velocity functions, and acceleration. Well, those are just derivatives of each other. So you have the position function s of t, derivative of that is v of t, and derivative of that is a of t. Or rather, I'll do it better. I'll do better than that. If you have the position function, s prime is velocity, and s double prime is acceleration.
Why have you come to coach the worst soccer team in the world?
The worst soccer team in the world.
Is this a joke?
But that's how it is. So you're gonna have to do that. So that's one main part of higher order derivatives. And pretty much what's gonna be on the free response. The other part, implicit derivatives. So don't forget implicits. How to do that. Remember vertical tangent lines. Is when dy over dx does not exist. Let me look. I was gonna go through the what's called the review and put examples, or write down which ones would make sense. So let me look at 25. Oh yeah, perfect. 25 is like the first is what I first said of the higher order derivatives. Actually, all of 25 is literally, yeah, all of 25 is literally the what's it called? What the free response looks like. Yeah, I can. After this one, okay? So all of 25 is what it's about. And then horizontal tangent lines. Is when dy dx is equal to 0. So all of this is 25. You can put on the in the card if you want. But I'm just saying what's going to be on the free response. So, yeah, we'll do the what's it called, the multiple choice on the weekend. Okay, so the entire second free response question is a table. The table problem.
Our ads catch the attention of new customers.
So like number 15. But it's not like you have a cosine or something like that. It's just like find h prime of x, h of f of x, and then it gives you a table. So something like that. So, you need to have a table, understand what a table problem is. So know how to like derive this f of g of x. Like what's that derivative? That's just chain rule. You should have this on your note card anyways. Yeah, you should know this anyways with chain rule. And maybe a product rule with the chain rule. So what if I put an x here? Like, what's this? So what's the derivative of that? It's different. You need to know inverses. So you need to know the fact that f, if this is true, then g prime of x, or the derivative of the inverse, is equal to 1 over f derivative of g of x. This is important. And then the favorite you need to remember what this means. Now, remember what this means. This is the limit definition of a derivative. It's just so all you gotta do is look right here and take the derivative of whatever that is. After that, it's pretty straightforward. That's all that's on the free response. Hope you guys know that. It's actually simple. Let me do number 25 though, because I said I would. You could pause the video if you need any of this stuff, but catch up. Number 25. How many questions are together? Okay, so on the first multiple, on the first free response, there is 6 A, B, C, D, E. So there's 5 parts to question number 6. But there's two parts that are different. So this is the first part of if this was question number 6, this would be the first part. And then I'll show you the second part, what it will look like, which is 25. And then on the second part of the exam, it is number 17, 1, 2, 3, 4. 4 questions.
Twisted tea is a refreshing hard iced tea made with real blue tea. Keep it twisted.
Yep. Twisted tea. Okay. So this is the one question that would look like on the test. Ew. The reason I don't like this is because I take the derivative of this, and that's just bleh. So if this is the position, all I need to do is find the velocity function and the acceleration function, and then plug in the values. Now the thing about this is this is a calculator problem. So we can actually solve this using a calculator. Let me see if I can pull a T84 calculator on here. Let's see, TI-84 Calc U. I don't have a. Well, I can have a camera, but I don't have the TI-84 on me. I wish I did. Yeah, I'm looking for one right now. I can't find a digital one. Okay, I guess I have to do this in person tomorrow, or push it off till later so you can do it. But what you would do is you would enter in this equation. You would enter that in to your calculator. There is a function. Remember the derivative function? It's not the fact that the lines intersect. It's just asking for like stuff like tangent lines and stuff like that. No, I won't give the answers tomorrow. But pretty much for this one, if this is a position function and is trying to find the derivative at 2, you can just find the derivative of s of t. And then at x or at t equals 2. And that would give you an answer on your TI. Yeah. Huh. So you can find the first derivative because this is a calculator problem. So you would enter it in on your calculator. Just like this. And I believe you can do it again. Actually, I don't know if you can do this one. I have to double check on the letter B. If not, B will just be taken off the quiz. That's pretty much how it's gonna go. So this one you have to use a calculator. The second one, so I need to show number 25. tomorrow, first thing. Uh-oh. What the heck is this? It's off. Yeah, I'll show you in class how to do it. Definitely. Verify this is true. You know how to do this. So all you got to do is find the relationship. So this one's actually simple because you go left and right. This is distracting. So you just go this equation right here. You have x squared is equal to -2 plus y plus 5 cosine of y. What's nice about this one is all the y's on the left already. All right. You got 2x is equal to dy dx plus -5 cosine of y dy dx. It's just that one specifically. And I'll tell you, you'll know it's like that's a calculator problem. I can't do that without the calculator. And I'll help with that one because I didn't think they'd spring that one on you guys. Plus, we didn't go over one like that. So, honestly, I might just value this one more. This wasn't that bad. Then you just divide it over. And then it asks for letter D for vertical tangent lines. So vertical tangent lines happen when it doesn't exist. It doesn't exist when 1 minus 5y sine y is equal to 0. So when the denominator is equal to 0. So that's 1 minus 5 sine y is equal to 0. Now, this one you can do on a calculator because all you do is you graph this and you graph this, or you see when it intersects 0, and that's what you get. So if I go to GeoGebra, and then graph it. I'm going to copy it over in a second, though. So and it says it's between values of 1, -1, and 11. So I got 0.2, 01, 6.48, 9.22. And that shows right here on the graph. Let me see if I can get these all labeled so I can show it to you. Points here, here, here. So I'm trying to get the values on it right now. So I would graph it and then see where it equals 0 like this. And now it asks for the equation with the smallest positive x value. So all we have to do is plug in the smallest possible y value. Actually, no. It's the one that will make this the biggest. Because when y is huge, it makes the denominator small. So we plug that y value, which is the biggest one, which is 9.22, into the original equation. Or we can plug into all of them if you want. Plug in this here, plug in this here, plug in this here, plug in this here. The fact of the matter here is cosine of y always belongs between 0 and 1, or negative 1 and 1. So this one doesn't matter. But this y right here affects it the most because that can be any number possible. So this y right here would have to be equal to 9, would be the biggest one, which would be our answer. You can't. You can't enter y into the equation. It's you just have to visualize it as if it were turned on its side. So like you turn your head a little bit, and then that's how you'd see it. Calculators do not like graphing non-functions on those. In fact, it's actually kind of hard to do that. So this one right here, up here, you have to use a calculator on this one. I'm gonna show you how to do this tomorrow on the TI. But this one you can solve by hand. Cool. With the y values between negative 1 and 11. Now, for letter D, it asks us, okay, so vertical tangent lines, you have to know how to do the 3 vertical tangent lines. So we just graph, hey, for what values is this going to equal 0? And the values it's going to give is 0. 0.2, 2.9, 6.4, 8, and 9.22 between negative 1 and 11. So for all of these values, when I graph this, because this graph right here is 1 minus 5 sine y, all these values is when this is equal to 0. So now we have to say, okay, for these values, which one is going to give me the biggest value when I plug it into the original equation? So I have all of these values for y. So y could equal 0.201. It could also equal 2.94. It could also equal 6.48. And it could also equal 9.22. So when you graph them on the TI, you just see where this line intersects 0. And then I just showed them that it's this one right here, this one right here, right here, Here, just like the systems we did for with the inverse problems. Yeah, it's for like the systems we did for the inverse problems. So now it's just like out of these four numbers, which one gives this equation the biggest possible value? And because this one's always going to change. It's a -2. This one's always going to be between -1 and +1. So the possibilities here is it's going to be the smallest one is -3, and the biggest one is -1 between these two numbers right here and here. So this y is the one that's going to affect it the most, which is going to be 9.22. For two, how did you turn it into dy dx? I didn't turn it into dy dx. This 2 right here gets canceled out completely. What turned into dy dx is this y. This y is over here, and this is right here. Because the derivative of 2 is 0. Yeah, this is a hard one. The next question, it doesn't show on 25, but on the test it asks you, okay, you found the 0 where the vertical tangent lines are. Now tell me where the horizontal lines are. And you're like, oh, okay, so that's when 2x is equal to 0 and x is equal to 0. And that's how you would do this. It's the horizontal tangent lines are at 0. And then if it asks you, okay, now where are they? You would have to plug that into the equation where it's x squared is equal to -2 plus y plus 5 cosine y. Where that's just 0 is equal to -2 plus y plus 5 cosine of y. I'll just graph that in the calculator. So I got -2 plus x plus 5 cosine of x. And once again, it's just where it intersects. 0. Oof, this is a tough problem. Oh. Undo. And these would be my y values. And if you look at the problem, like the picture. You can see that the points that I just listed, negative 9.4 is right here. Negative 1.46, one's right here. 0.46 is right here. And then 4.24 is right here. No, we don't. We just have to visualize it that you're trying to find the zeros and then turn it on its side, right? So just look at it sideways. You can't actually graph it with the y in mind on the calculator. And if you can, it's actually pretty difficult too. But the fact of the matter here is y is just a variable. Y could be x. Now, does that represent a horizontal movement? No, it represents a vertical movement. But we have to see if we can use that to our advantage. That, hey, it's just a system. 0 is equal to this other equation. Okay, so that's when the answer to the problem is when this equation is ever equal to 0. Now, all in all, after me seeing this and seeing how a little bit more complex it is, let me double check. How a little bit more complex it is, I'll be more lenient in grading this one. Just because it's more along the lines of a calculator, and if you know how to do a calculator problem, rather than if you know how to do the calculus. Okay? But this is the main thing. First thing tomorrow morning or tomorrow afternoon, we're going to do this in the beginning of class. And then second half of class, we'll try it. Sound good? So on the second part of the free response, you're going to have to do a chain rule, and there is going to be a chain rule in a product rule into a chain rule. And then there is going to be an inverse problem. So if you were able to do all those problems in the beginning, you are more than well prepared to do this. There is no equations. You have to do a chain rule, so you actually do not need to know any of the like inverse tangent or inverse cosine type of rules or du dx or any of that stuff for the entire free response. So if you're studying, it's not worth memorizing those rules at this time. We are taking the test tomorrow. What's more important is if you know the circumstances, the chain rule, the product rule, the chain rule into a product rule, or the product rule into a chain rule, the inverse derivative, method 3. Implicit derivatives. Yeah. And I'll tell you the implicit derivatives, it's pretty much all power rule. You just have to make sure you have everything correct. So that's the extent of derivative knowledge you need to know for the free response. Is don't focus on like trig or stuff like that. There's none of that on there. Should you still know it? Yes. Should it be on your note card? Yes. But for tomorrow, you do not need any trig. You do not need any natural logs. You do not need any e or any of that stuff. You just need basic power rule and understanding of product, chain, quotient rule. And that's it. The calculator section is another story. We will go over that tomorrow, first thing. But that's pretty much it. Yeah. So what I mean by like product rule, like you should definitely know how to do chain rule. Like f of g of x, like find the derivative of that, you should know how to do that. If I do h of x times f of g of x, you should know how to do that. Like in this form. Like you should know how to do it in this form. Should I do it? I'm just doing it. I'm just doing it. So if I have, this is automatically a product rule with a chain rule involved. So I'm just going to put u in v and say that's going to be my first function. This is going to be my second function. So I can just say, oh, this is just product rule. Cool. And then do one step at a time. The first term is u prime, so it's this. So I'm going to have h prime of x times v f of g of x plus u, which is h of x, times this derivative. So the derivative of this is just chain rule. So derivative of the outer function, where the inside stays the same, multiplied by the derivative of the inside. So the idea here is this whole thing right here, it's v prime. This whole thing right here was u. This right here was v. And this is u prime. So it's a product rule, but it had a chain rule involved. Now, this kind of problem would have like a chart next to it saying that, oh, okay, so here's h and here's g and here's like 1, and you have to like plug everything in, 2 and then 3, and then there'd be like an h prime and a g prime, and it would be that kind of problem where you have to figure out, okay, now plug in 2 and tell me what you get. So that's the second, the non-calculator part of the exam, is you're going to have to know how to do things like this. And they're like, oh, okay, now tell me what the derivative of this is. F negative 1 of 2. What's that equal to? And then you should know that it's just like, oh, okay, so that's just equal to 1 over f prime of f inverse of 2. Because you wrote that on your note card. And don't forget the limit definition of a derivative. There is not a delta math. And I don't think it would help. Let me check if there's delta math actually. Okay, the assignments, calc, implicit derivatives. Okay, nothing there. Let me see if I can see if there's anything. I'm trying to see if there's anything with a table. Yeah, looking for a table of problems for this, and I do not see any. And the only thing I do see is inverse functions. I mean, here I'll assign stuff that I think would be useful. There's a couple, but there's not a lot. So I'll assign one. Unit 3 FRQ review. So it's literally just table problems. No penalty. And then like inverse functions. Yeah, this other one, there's nothing gonna help for that one. And then I'll do this one too. Right derivative as a limit. Find a horizontal vertical tangent. Estimate derivative of a graph. I did this one too. This isn't a required assignment. It's just practice. Now, the one I was looking at, just so it's on the video, it looks like this. Let me scroll down. So a problem that looks like this is important to know how to do. So this knowing that G is equal to the inverse, so that means I know that G prime of 1 is equal to 1 over F prime of G of 1. And then you would have to just do it correctly. So G of 1 is equal to X. Now G, remember that's just F prime, or F inverse, sorry, of 1 is equal to X. And then we have 1. It's asking us what value of X gives us an answer of 1 for F of X. So I look at F of X, look for 1. See that it's right here. So F, the answer of X, it's 4. So I know this is equal to 4. So now I have G prime of 1 is equal to 1 over F prime of 4. And F prime of 4 is just -5. So you're gonna have to know how to do that. In fact, this makes it this makes like there's a pattern here too, because if you look at this was the only road that was used, because we found the answer that gives 1 is 4, but the derivative at 4 is -5. So if we do another one like this, and we say, oh, here's the function right there. Okay, so I have f prime, f inverse prime of 8. That's just g of 8 is equal to 1 over f prime of 8. Oh, sorry, not 8. Of g of 8. So what's f inverse of 8? Which answer or which input gives me 8? And we see that it's -5. The answer of 8 is -5. So I know my input's going to be x equals -5. But now it asks me 1 over f inverse of -5. -5 right here. F inverse is, sorry, f prime of -5 is -2. So it's been 1 over 1 -2. Just like that. It's honestly like you have to know like stuff like that, or like, hey, how about what's this derivative? Cosine of x times f of g of x. So what's that derivative? Then you start realizing, oh, okay, so this is u and v, so it's a product rule. U prime v plus u v prime. Negative sine of x times v, which is f of g of x, plus u, which is cosine of x, times v prime, chain rule, f g of x, f prime g of x, times g prime of x. And that's the deal. It isn't gonna be super extensive like the review in the beginning, but this is what to expect. Okay. On the implicit derivative, there is no chain rule, there is no product rule. It's just, remember, when you take a derivative of a y, you get dy dx. When you take a derivative of an x, it's nothing. Well, there is no dx dx. Dx dx is 1. Any more questions before I get off? Now, I want to remind you there is another study session this weekend for the multiple choice. But that's just it. Okay.
Level up your house color outside.
All right. I am going to get off then. If you have any questions, email me. We'll go over the calculator problem tomorrow. I'll see you guys tomorrow. Later. What happened?
We didn't have drop.
Andrew, what happened? Later. Yeah, my girlies.